I'll be limiting the GSI's work up to glaciological observations and the readings we have taken. Our main idea is to go for the mass balance of a sector in Antarctic polar ice sheet, actually. So, without going into the details of background information, we'll just narrow down into two specific papers in Nature, which actually are very well read. This is the first one. While computing the mass balance of Antarctica, the authors or the norm they have developed is they have divided the whole continent into different sectors according to based on drainage basins and other parameters, the whole ice sheet. And then they, if you see, they calculated each sector wise the health of the polar ice sheet, wherein in the West Antarctic side they have shown there is a loss. There is a loss of this thing, water, melt water, and this side has been on the positive health of the polar ice sheet. And but we go for the another one. We see the result is around 82 gigaton per year, the total Antarctic scenario. But the problem is that in many of the sectors, the human beings probably cannot reach, and it is done by remote sensing and some ground truth validation from the neighboring sectors. Our such huge is the this thing area that our area, the Indian this thing station is around in the 6th sector, and if we zoom this sector, this is the total Hana Atoll 2013. This is the scenario of the mass balance of Antarctica, where they have used different models and there are different parameters of these models, and we see there is more or less just a minute. More or less we see the mass balance is restricted to this place. So if you see the sector 6, and we am just narrowing down this sector, and this is the central dawning model, where the mad ice program is also going on in the ice shelf area. And in this sector 6, we narrow down the central dawning model, and this is the small area. So if you see, we hardly have around 100 kilometer by 100 kilometer square area where we can actually reach and do the ground validation and the studies. So we have taken up the program in this area. This is the this is the zoom of this area, and this is the area where we are working. And just a minute. And this is the Simachar Oasis, and this is probably the edge of the Antarctic continent, and where the rocky exposures are exposed, and where we have the this thing, the retreat of the snout, or the edge of the polar ice sheet retreat. So measurement we have around, say, 3 decades of measurements is there, and from here to this Holtut Mountains, this is a traverse of 100 kilometers, where we have, this is the polar ice sheet basically, and this is the shelf ice towards the ocean. So we have been doing the glaciological studies in this area of 110 kilometers. Roughly it is a distance of 110 kilometers, and we want to extend this to up to 100 kilometers this way. So we have a 100 kilometer by 100 kilometer grid. So here we come to the observations which we made. Last year we took a traverse from the Simachar to the Holtut Mountains, thereby going 110 kilometer and returning 110 kilometer. And in this we did find some crevasses and all. So we tackled those, and what we did the basic measurement of continuous ground penetrating radar using the low frequency MLF antennas. We did the DGPS studies, we used a total station, and so this was the array with continuous GPS survey has been conducted in for say 320 kilometers, and then we have this flow velocity measurement using the DGPS stations. And this time we installed around 25 DGPS stations new to get a profile of the area. And then these are these locations of these DGPS stations, these red points. And with these DGPS stations, we first time developed a profile of this area from Simachar to the Holtut Mountains. So we we first time we have a ice profile, the polar ice sheet, which we imagined was flat. It isn't. It wasn't flat. It has a contour, and these were the DGPS locations put on this contour. And then with the DGPS, we did 3 months. After 3 months, we repeated this experiment this year, and last year rather. And then we found this velocity of the polar ice sheet at different places. As Thamban had already told, the velocities are enormous in these areas. Where we found around 70 kilometers per year annual velocity is also there. So this year again the annual measurement is going on. So we'll be able to constrain it in a much better way. And then this was the horizontal component of the Simachar oasis. We can skip that. And in the last 2 decades, we have a continuous data of the retreat of this polar ice sheet in the Simachar region. So these are the data. This has been collected over the years. We have actually more than 3 decades of data, but the continuous data is from 1996. So these are the data in front of you. And there are recessions. These are the plots. So these are the western wall, that another part of the polar ice sheet. It has sunk over 25 meters in just over 10 years, with a maximum of around 11 meters in 2002-2003. So it is sinking fast in the Simachar area. Then again, coming back to the convoy which we took last year, we developed another stake networks of 25 stake farms of say 20 stakes by 20 stakes farm network. So where we can measure the snow accumulation abolition, that data also we need for the polar ice sheet. And then overall accumulation on ice shelf, and then stake network at ice shelf. This type of stake networks we can see, and then these are the tabulated data. And then just plotted this accumulation over the years on the polar ice sheet and ice shelf areas. So, and then over the stake farm, if we plot this, so we also see the drift direction of the wind along with this snow accumulation. So we have a sense of the drifting of the snow, wherein in Antarctica it is very important to separate the drift with the actual precipitation. So we have to separate the 2 components. And these are more figures of that. I'll go quickly. So snow accumulation similarly on polar ice sheet. These are the stake farms. Again, this type of graphs, and then snow accumulation pattern along ice shelf margin from polar ice sheet east of Simachar oasis. And then the ice thickness study by using the ground penetrating radar. We have the contour of the ice previously available from the Russian geologists. But then this ground penetrating radar, we developed this profile, and now first time we are able to have an idea of the thickness of the ice from Simachar to Holtat mountain of 110 kilometers. And along with this thickness, and the DGPS elevation contour, so we exactly know the dimension of the ice in 2 dimensions. And we intend to make some across traverses this year, so that we actually know the volume of the polar ice sheet in 100 kilometer by 100 kilometer block. So that is one thing. So these are the profiles. It's not. Yeah, I can conclude, no problem. The thing is that we have developed the profile, and we have the DGPS measurement, the surface runoff. So the next step is to go for the mass calculations of the polar ice sheet in this region. Thank you.